page 33, number 36, we'll prove that the differential equation dy over dx equal to the ax plus by plus c all over the capital of A times x plus capital of B times y plus capital of C can be solved as follows. If A capital of B is not equal to B times the capital of A, constants h and k may be determined such that the equation may be transformed into a homogeneous equation in the new variable u and v by the substitution y is equals to u plus h, x is equals to v plus k. So we have the equation dy over dx is equals to y plus 2 all over x plus y plus 1. So substituting y is equals to u plus h and x is equals to v plus k, we now have du over dv is equals to u plus h plus 2 all over v plus k plus u plus h plus 1. So getting the values of h and k, we have negative 2 and 1. Substituting this value, we now have du over dv is equals to u all over u plus h. Transposing du and dv, we now have u plus v du is equals to u dv. U plus v du minus u dv. And since u is equals to yv, we take the derivative of u. We now have du is equals to y dv plus v dy. Substituting these values to the equation, we now have capital yv plus v times the quantity of y dv plus y dy minus yv dv is equals to 0. Multiplying, we now have y squared v dv plus yv dv plus y squared v dy plus yv dy minus yv dv is equals to 0. So y squared v dv plus yv, quantity of y plus 1 dy. Since yv dv are cancelled in the equations, dividing quantities in y squared v, so we have dv's plus y plus 1 all over y dy is equals to 0. Integrating, we now have v plus y plus ln y plus c is equals to 0. So ln y is equals to negative v minus y plus c. Taking is exponential, so we now have c is equals to e to the negative of the quantity of v plus y. So y is equals to c all over e v plus y. Since y is equals to u over v, we now have u over v is equals to c all over e raised to v plus u over v. Since u is equals to y plus 2 and v is equals to x minus 1, we now have y plus 2 all over x minus 1 is equals to c all over e raised to x minus 1 plus y plus 2. Transposing, we now have y plus 2 is equals to c x minus 1 all over e raised to x plus y plus 1, which is our general solution.